us start. Is a talk on product design and development through simulation. Now, what is this product design development? First, let us see what is the meaning of product design. And let's see what is the product. Any device or system that is designed and produced for use by a customer. Now, the moment we talk about product, normally it becomes, we feel that it's a physical product, which you can feel, you can touch, we can sense. And this is there in our day-to-day life, damage doesn't. The watch you are wearing, the cell phone you are having in your pocket, or the television you are watching, or cooking essentials in your kitchen, everything is a product because that is being used for achieving certain designated end. So the moment we talk about a product, it's a device or system. It may be hardware, it may be software, it may be physical, it may be virtual. If you would have talked a product as virtual about 50 years back, it would have been surprised. But today it is not so. And the biggest example of that is the software. When you go for buying your ticket today in airlines or railway or buying ticket for movies, everything is done through software, which is not visible. But the end result is very much visible to us. And that is most important for a customer. That what I am intended to have, whether I am getting that done or not. So it may be basically physical or it may be virtual. So when a product is there, we need to design. That is a process of making a dream come true. How do I make? I thought about that. I am having a dream to make it happen. So there is a design process which makes that dream to physical reality or a virtual reality also. Now both together, product design becomes product design. Is to create a new product to satisfy and solve the intended purpose or problem at hand through a physical entity, services or software, and is done through a process of an efficient and effective generation, development and implementation of ideas. Please mark these three words: effective generation, effective development and effective implementation of ideas, so that we are able to solve certain problems which are there. Or the problems may not be there, but looking at the future, based on the technology we have in our hand, on probability of technology development in future, based on the current technology we have, we are going to get some effective physical or virtual solutions. So in brief, it is a translation of intellectual wisdom, requirements or needs of the situation to address a problem or situation. Now, all this product design is based towards a person, a customer. So who is the person, who is the customer, who ultimately buys the product? It may be from your organizations when you are doing the design. It may be about the customer whom you are not going to see, and who is going to get affected by this product. And chief objective of the product design is satisfying the customer's requirement. How the customer is getting satisfied by these things. So if you look at the screen, we have all multiple different types of products in the arena. Some of them are physical, like aircraft in the center, or it may be a robo in your automobile assembly line. It may be a bridge making across the harbor. It may be a satellite in great space, which is giving us. So a lot of these products have been built up. Some of them have been to solve the current issues. Some of them have been built with the technology. For example, a great example of them is space technology. Nobody knew why space technology, this kind of satellites are supposed to be giving solutions. Today, if you look at this as space technology, it is satisfying the agricultural need of a country. And in this context, I should say, India has grown a lot. Today, we can actually tell how much will be produced of the country in during the crop season. Whether we can have any kind of calamity, natural calamity, and the warning will come to that. And currently, if you see, the eastern coast of India, which faces maximum number of problems through the Bay of Bengal issues, has been created well in advance, and there's a reason loss of life is very minimal. Loss of property is also minimal. So if you think this technology 50 years back, it was not thought of. But since we have developed the space engineering, space technology in our country capability, we have extended that to a societal impact, a huge societal impact. So when we talk about a product, it's a basically open system, which has got a well-defined boundaries and then surroundings. Thermodynamic principle says the total entropy of the system will be remaining same of the universe. So this open system, this kind of things which has got some input and should give you output. A product is like that. It will take some input from the surrounding and to give you output which is required. Now, sometime in the course of this discussion talk, we'll see we have not intended to have that product. We have not thought that the output will be like that, and it has come through. Many of these are very accidental products. So, what is it to develop? Should a completely new product be designed? Sound is coming. So, should a completely new product be designed? Original design or invention? Means it should be totally new or to be invented. Now, original design in the sense the problems at hand, how do you address the problem?
Is it by your you have provided some effect for slide to निकालना चाहिए ना? But वो थोड़ा ऊपर ऐसा आ रहा है, चलेगा? Sure.
Should the existing product be redefined and modified to better satisfy the customer? So this is the kind of things where it is already used. For example, I'll give an example of television. Television was there in the box type. Now today there's no boxes there. It is history. You have a panel basically. The whole technology has changed, and just to satisfy the customer, the quality of the sound. And this is very interesting things. Earlier we used to have telephones which are there line based. Then we thought of can we have a cordless telephone, which was done about quarter century back. And then why will you have to have this cordless and all these things? Can you go anywhere and talk to people across the country, across the nations? And that gave birth to the concept of mobile phone. Today we can use mobile phone not only for talk purpose but for every other purposes. In fact, interesting if you see if somebody can do the study, they'll find out the use for mobile technology, mobile cell phone for conversation purpose is quite low compared to the other purposes like different messaging platform, different viewing platform. And in fact, I can say we do not need television in today's world. The cell phone is sufficient to do the thing. It is done through adaptive design, evolving a new known design. Third important point, should the product be expanded to variant forms to more comprehensively cover the market? I'll give an example. We produce car in this country. In fact, a very important thing I should say, till mid-90s, no Indian companies were making any automobile car in this country. All were exported, got a design from abroad, and we used to make. The Tatas were the first to produce car in this country from scratch. And if you look at the last quarter century journey of this vehicle, it has gone through many variants. And today what we see, it has gone to the extent where the quality can be as best as the world can give from any other developed countries. Like variant design involves varying parameters, size, shape, and materials. Some of the engineering products, and I can tell more interestingly, these all the things are reflecting what India can do. Look at the metal industry. We are manufacturing this kind of sheet metals, hot sheet metals, and of great variety, great interest. 40-45 years back, the strength of these materials in this produced in this country, our country, was what? It changed to almost twice the strength in last 45 years. How does it happen? This is a product. Why we need this? It is used for the advanced purpose applications like automobile industries, the strength, the sheet metal. And if you think the sheet metal thickness is 0.7 millimeter, which is used for your car body, made in India. Similarly, if you look at the kind of crane industry, we are one of the best crane industry manufacturing in the world now. Same thing for the solar industry. In fact, the way we are planning that the solar power will be one of the major source of power in the country in another decade time, other than the normal traditional form. So these various engineering products are there for these things. So what is the new product? Couple of points I gathered from the different literature. New to the world, absolutely new, which is about 10% of the new products. New to the firm products, 20%. which is basically that take a firm into new category. Third is additions to existing product lines, make it 26%. Which is already there, we have just adding some things like aerial liquid soap. Improvements and revisions to existing products. Current products are being made better. And different exports 26%. Repositioning the product for targeting new applications to the user. Cost reduction 11%. Out of all these things, if you add them together, it will be 100% of the total product. So absolutely new product today's world is 10% compared to about 4 to 5 decades back when this portion was much better, much higher. What are the function and importance of product development? Three important point comes: marketing, design, manufacturing. So if you see, when you're marketing, you're interacting among the firm and its customers, so that find out what is the requirement, what people feel. So there are two things we'll discuss in a couple of slides down the line. One is the feedback which comes from the customer. Another is where we have a technology in which we are going to produce something based on new technology. Second important function is design, which plays a lead role in defining product engineering design, industrial design. Third is manufacturing. I can design a beautiful product. Can I manufacture? So all these things together are very important aspects of the product design. What these products have to all these things, I've given examples of 4 or 5 products. The Apple computer, the Nokia mobile, which is regulates the whole concept of telephone, cell phone concepts, Gillette razors, and kitchen grips. What they have in common is the developers understood the customers and their competition, both. So they created products that met or exceeded the customer's expectation. I felt that I should be having good view or good computing capability, but I got much better than that. My expectations gone. It has succeeded my expectation. So what is this product design? Basically, we have to work about 2 things: form design and functional design. How the shape and appearance of the product, there is aesthetics, tangible goods and services. Now I'll give an example. What is the meaning of this tangible service? You are going to a bank. The moment you enter a bank and somebody comes, welcome sir, welcome madam. We have got a beautiful product for you in our bank. What is the meaning of this product? You got a fixed deposit or recurring deposit or some kind of investment, and you need not come to bank. You will take care of your things in sitting in your home. So these are tangible service which are not thought of earlier that can it be a product. We can think the product, the form design. Functional, how you are getting the work, capabilities. So that leads to 2 important aspects called product design and industry design. Product design includes engineering design, physical product, services, software. Whereas industrial design is aesthetic form, appearances, craft design, ergonomics. So both together gives a new product output. And this is a cycle of product design. 5 important points: product development, form design, functional design, packaging design, and this product research. This product research purpose basically tells me what kind of things customer needs or what it can offer to customer. Customer may not know, but based on the technology we have, we can tell this is a new thing we can bring to customer. Then we start developing the product based on this, and we give this to attend this to form and function. It should be good form. For example, when you are using a safety razor, grip should be proper. It should not be very light, not be very heavy. It should do the purpose. Functional, it should be smooth when you are shaving. Or if you are using for example, the remote in your television, it should be easy functional. How do I package? How do I put the whole thing so that it looks and also function-wise better? That's why I say these are the product design category. Demand pull, invention push. Demand pull means market. With these opportunities existing in market. So how do I attempt to solve this problem and for new purpose? Second is invention push, that is technology push. And we have advanced very much in technology and knowledge. How do I use this to reach a new product design idea? Whereas, so if you look at the bottom figure, technology push is research and development, production, marketing need, you have to say. Whereas market pull is we need this express market need. Based on that is coming from marketing, and then we go to R&D and make it happen. So these 2 are 2 different aspects, but both gives the solution for product design. And I have just given product design category, market pull, technology push, These are then platform products. All these things are put together. Okay, depending on the kind of product it is there. So platform products, process intensive, customized, high risk, quick build products, complex systems. Complex system like space shuttle, example. Quick build product software, which is used everywhere. High risk is nuclear power plants, drug relevant devices, because both are involved in safety aspect of human being. Customized product, boiling water reactor processes, very important. The examples are given in this. So when you're talking about this product design, so naturally you have to have some kind of process to do. So there are two aspects comes, a product design process and product development process. Product design process is the set of technical activities within a product development process. Product development process is mother. Daughter of that is the design process. And this product design process does not include business, financial, or marketing activities. It's purely technical aspects. Keeping in mind the form and activities of the product as there's no harmful output comes to the product. Second, it is easy to operate and is intelligent. Well, the product development process is the entire set of activities required to bring a new concept to state of market readiness. So, as Urvish and Apin, they are very prominent. Both of them are practicing engineers, become academicians, and concerned to many firms. They have given this in 6 stages: planning, concept development, system level design, detailed design, testing, refinement, production, and planning. All this vision approval, concept review is there. We review the things. Then system specification review after designing is over, and then critical design review, detailed design and testing and refinement. This is a very important cycle. After we get through all things, we go for production and go to the market. So why study the design process? There's a continuous need for new, cost-effective, high-quality products. Today's products are complex and require a team of people with different backgrounds to take an idea from concept to market. A couple of decades back, it would have been easy, much easier. A single person or two other persons can make a product. But today's world is quite different. Multiple team activities should be made together, sometimes parallel, sometimes consequentially. So this product design process is a set of strategic and technical activities from concept generation to implementation and systemic approach. As outlined by Coburg and Wagner, it follows a guideline involving 3 major steps: analyze it, conceptualize, synthesis. Again, this now got different stages. You can go and refer to this work by Coburg and Wagner. Analysis divided in 2 stages: concept 1 stage, synthesis 4 stages. These are explained in my paper earlier. Product design process is basically 3 steps: understand the opportunity, develop a concept, implement a concept. I have given an example. Did I understand? Did I get a vision for doing? Can you develop a concept? And based on that, can I implement the concept to manufacture and usually customer? So what product we like to be out there? Why does it not do something we want it to do? What is difficult with the current product we use? Every user has thoughts on how they wish their device should work. Everyone, all of us. Whether scientist, whichever has a vision that the technology can be applied, or a manager who has got a vision, a command of the market. The question is whether any vision can be transformed into successful reality. Can it be developed and implemented into profitable product? So remember, this is an important aspect from financial perspective. I have invested money. Can I get an output of that? So this is a process. Now, next 2-3 slides, briefly I'll talk about a go/no-go decision on a new product. This is measured by S-curves, technical question, mission statement. Out of this, I'll talk about this curve. Very interesting. It is best explained through a S-curve. I'll show you the next slide. Technology innovations typically manifest themselves in the market along an S-curve timeline behavior. It is over a time. 2 examples I'm giving: light technology, lens technology, digital technology. Over a time, it is how it is. So stage 1, characterized by a little low performance, not much innovation. It's just we started. Another example I'm giving of fluorescent light and incandescent light, which is developed last 150 years time almost. And see how the development has taken place. Initially, it is slow. It will not pick up so fast. And technology is not changed, so it is going to mature. Sometime other technology should come up. Second stage, rapid growth due to many innovations, many products introduced in the market. Very fast growth will be there from stage 1 to stage 2. This is stage rapid. Look at this, how this growth has happened. Then, third stage, it matches. Tops out, product may become obsolete, it may not be used that way. But what happens by the time I've got a second, another technology coming up? Like here, light lens technology for copier purpose, it becomes digital technology. Look at the kind of growth. And it's now almost getting saturated. Possibly we have another technology coming up, which will now push this channel and create third S curve. That's the kind of things on our. So the S curves show the market behavior of most technologies. A switch to better technology is known as jumping S curve, as I mentioned. The newer S curve is disruptive technology that triggers changes in the market system to succeed. Like DHS, DVD, HDTV, all these things are coming. Last 3 decades, we see the television viewing has changed a lot because we are getting new technology which is jumping. Industry is constantly this jumping because that's right. What we have today may not be available after 5 years' time. And design team must consider this technology environment in introducing new product. Are we using the latest technology for introducing a new product, or it will be obsolete in no time? So although most technologies follow this path of market, there are exceptions, like Moore's law. Transistor density on microprocessors will double every 18 months. And this is a very interesting aspect of our all devices we are using. So this is a little bit more elaborate towards PD process. Planning, like today I can give an example. Auto complacency is energy crisis, needs better gas mileage. So concept development has to be done. When I'm going for that, I need to see the transmissions, more speeds, better mileage. How they increase the speed. So system driven design, do we need a 3-speed or 4-speed or continuously variable gear systems? So that leads to detailed design. Clutch is needed for full throttle applied to the current design. You need this design limit. Then when I get intelligent testing refinements for this 4 phases of product development starts from this to this level, and then manufacture. So interesting aspect of that. Do I understand the requirement? Do I go for better technology? Today we have got to punch together the kind of technology we have and the kind of requirement we have. So how do I do? And also when I develop a product, does it go have a capability to augment that technology? An example, product concept, begin product. So look at this design process activity level. I get engineering mature, then going down. What is the manufacturing industrial design? This is a point of interesting thing. It's a non-linear process completely, all together here on the problem. Now, if I develop, what is a successful product design? Market-driven economy. Today's world is market-driven. Successful product development results in products that can be produced and sold profitably. Heard about Dell companies lately? How do I get into the market and keep myself on all the time? By bringing good products which will be satisfying and fulfilling the requirement of customer. The customer wants it. So when I go for performance aspect of the successful product development, these points are important. Product quality, product cost, development time, development cost, development capability. I need to have a good quality product and good cost. I can't use a long time to develop product. By that time, my competition or maybe the technology is changed. I can't put a lot of cost on the development, or that my product cost goes up. So I have to have balance of all these things. These are the important factors which actually dictates the kind of performance of product. So a little elaboration on that. Measure. How do I measure the product? Product quality. How good is the product? What is the kind of things intended? What was it satisfied now? Cost. What is the manufacturing cost? And bring it to the customer. Development time. How quickly was the product developed? Development cost. How much you have spent in developing this product? And capability of a product. Can the team be better able to develop future products based on the technology or based on the product? Does it have that augmentation purpose? So, 3 measures of product development and duration may vary from only to 10 years or greater, depending on the type of product. Cost, quality, and time. It's very important aspect. These 3 together, none of them play short, lower, or higher. Today's world, that is the thing. 21st century, this decade or third decade is important to look at this. I'm talking about the different development and design process. Phase 0 plan, phase 1 concept development, phase 2 is system development, phase 3 detail development, 4 is testing and refinement, 5. These are the things which is discussed in a box form and giving the details of. This planning begins with the strategy and assessment of technology developments and market objects. Both are I'm addressing. Market pull as well as technology push. Both I'm talking about this planning aspect. Phase 1, concept development. It's a techno actual product development starts work. I've identified the target market, alternative product concepts are generated and evaluated. Phase 2, system level design, where definition of the product and breakdown into subsystems and components has been done. That is very important. Third is detailed design, complete specification of geometry, material tolerance, manufacturing details. So it goes for prototyping and further. I have all the details with me. So how much measurement should be there, what kind of materials, what kind of manufacturing tolerance should be there, so that my product performance is what I have intended to plan. Then testing and refinement, so prototype evaluation and assembling testing, utilize prototype tooling. I'll give an example of this fourth one, whether it's a software industry or not. If you look at the software industry, we go for a bank. Today, there is no ledger, physical ledgers. All are physical and software. Anyone who is 50 years or older, they have seen this ledger business and they feel big files, big notebooks used to be there with the name of the customer and the details will be mentioned, the input amount, output amount, tracing, interest status. Today, all things have been put in the system software. And when we test it, we find out whether if the interest rate goes up or interest rate goes down, can it automatically implemented in the software? That's the open basis. So that's why the testing and refinement is very important. Then once it is done, we go for the production ramp-up. That is completion of production tools and process to implement manufacturing process as well as trained workforce. Now here again I'm going to give the example of banking industry. Today in the bank, all the people, the peon or a cashier or an officer or a manager or senior people, they're all very much trained in the kind of software they use for working. These are different steps. We'll not go much in these things in details. So let's see what are the challenges. We have talked about the way we can design the product, the kind of success which is required for a product to be on market. What are the challenges? Trade-offs. The need to recognize, understand, manage them. What's the Boeing 777 metal used? Composite materials. The interesting aspect, majority aspect of the Boeing plane is composite. We have trade-offs. Dynamics, constant changes, new technologies, customer preference, new products from competitors, and now a green economy focus. Transmitted is a very important aspect of this. The big three in automobile, the economy and access to credit. All these are very much changing over the time. Now, if you look at the customer, the change in technologies, look at the vehicles we are using today. I mean, you have seen the vehicles 30 years back. Huge amount of changes has come over there. And in India, we have now got vehicles, automobiles, cars, or scooters, two-wheelers, or three-wheelers, where we do not have to put pedal on to start in your scooter, or motorbike, or your three-wheelers. A push button is sufficient to start your engines. Good improvement has happened. Good mileage aspect has come. The wastage is less. Your environment is getting better. Detail. Each small detail can result in increased cost. So how much I should do, how much I cannot say I will not need, so that the cost is controlled. Time pressure. Time is money for this today's world. And you have to make decisions quick and without complete information. Lithium-ion batteries for Chevy Volt vehicle. Is it really good? Because today you are talking about electrical vehicles. How much I should put that? So time pressure is there, economics. There's a lot of money involved in to develop, produce, and market a new product. Products have to be appealing to customers, natively inexpensive to produce. New electric design. I can't ask for $1 million for electric design or engine. I need to see that how much I can do. And taking into account the cost aspect, quality aspect, time, and its utilization, and the life of the product. So what are the risks of this? Is the product technically feasible? Can you make it in a reasonable time? Is the product economically feasible? So technical economic, both we are talking about. These are answered by two issues called technical question, mission statement, and product development, which we are not going to touch much in this. But you see another interesting aspect called cross-functional team characteristics. Product. 21st century needs this. And why some of the products do not function properly? Because of lack of team empowerment. Team leads micromanage. We should have a proper team which can have cross-functional aspects as well as functional elegance, overpower project goals. Silo mentality should not be then productive. I know this much and I will not allow. No. We should be open for all kind of inputs and we will be open to discuss and see that the end product is good and is satisfying the customer requirement. Inadequate resources, people, skill mismatch, money, equipment, tools. I want to design something great with the software in CAD and CA environment. Do I have the required people who has got required skill? No, then lack of cross-functional presentation. Decisions made without representatives from marketing, design, manufacturing is very. I cannot be a good product developer unless I have a good team of all these things. What are the benefits of integration employee capabilities? Product development is an interdisciplinary activity. So when you're talking about this, I need to have a very strong cross-functional teams which gives all the things. And today's world, if you see, the best of the best products are being done by Indians, whether you talk about in India or abroad. The top 7-8 organizations in the software development and other issues are all Indians. And we are very proud to say that we have that kind of technology push in our mind and our thought process. And we are able to make it happen and show it as reality. Some points to ponder. Document your thoughts, your observations, your markups, everything. This is the aspect we should change in the Indian context. We are not very good in this. Whatever you are thinking, we should immediately keep it in writing, keep it recorded. In the Western world, this is a little better than India. Try, fail, improve, learn, try again. Also think, build, test, follow. Study, share, listen, combine. Plan little and do a lot. Very important aspects. So when you are working as a team, we have to share, analyze, organize, and explain our thoughts to each other. So to reach a concrete goal. That reminds me of the statement which I have given already by Albert Einstein. The mere formulation of a problem is far more often essential than its solution, which may be merely a matter of mathematical or experimental skill. To raise new questions, new possibilities, to regard old problems from a new angle, because creative imagination marks real advances in science. This is possible when you actually follow this kind of things which I mentioned here. Right, fail, improve, learn, observe, think, build, test, follow. This. Now, we have touched upon the simulation aspect earlier also, but briefly I'm talking. Technique for studying real-world dynamical system by imitating their behavior using a mathematical model of the system impedance single on digital computer. Now, so far we have talked about product design. Now, what is simulation? Now, I have to make the product. Do I have to go physical? Can I do simulation in virtual world? Today, we have got the technology. So we can actually start thinking that product. So to understand how do I simulate, I need to understand what is the meaning of simulation. It's a mathematical modeling of the system, of the product we have. And we need to do, as I mentioned, we have to know the input which is there in the product, output which is intended to have, and what conditions the product will be used. So briefly, can be simulation is a simulated system imitates operation of actual system over time. Artificial history of system can be generated and observed. So I need not create a physical system before that I can get the things. So why simulation? How to use it? It enables one to perceive the interactions that would otherwise be apparent because of this separation time aspects. How to use the simulation? Develop a model, simulate it, analyze the results, learn the from simulation, revise the model and simulation, continue to this interaction. So model. What's model? It's a physical representation something or mathematical representation or abstract representation of the product. We talk about the turbine, talk about the treadmill bicycle, or talk about bearing. These are the different models in different things, CAD and CA environment. Different types of models, mathematical, physical process. We have discussed this in our first talk, but just briefly touching. And again, based on concept, it can be physics-based modeling, Entitlement modeling, database modeling, agent-based modeling, aggregate modeling. These all modelings are important aspects for understanding the product and simulate the product to requirement. Model classification of the product, formal versus informal, physical versus abstract, descriptive versus analytical, hybrid versus analytical, domain specific versus system. So modeling is basically development and model of the product. Why you need to spend so much time? It's easy for understanding the product. It's a mathematical representation of a system of product. It depends on your goal, how they do model. Main goal of modeling engineering is conceptual analysis and detailed simulation. This detailed simulation is very important for giving good product goals. So classification will be based continuously. I can simulate or discrete, depending on the type of the product I am at hand. Different applications I am mentioning here. So with respect to state variables changes, distributed continuous simulation aspect, respect to entities involved, live, virtual, constructive. Okay. With respect to time advance, discrete and continuous as mentioned, with respect to results, deterministic, stochastic, traditional, agent based. Deterministic, I need a firm answer. Stochastic, I need a statistical, like that. So simulation model development. Identifying the problem with an existing system or set requirements of a proposed system. So these are the kind of model development simulation we have talked about. The 8 steps are there on which we can do the simulation. Performing a simulation, the different stages are there. This simulation is important for seeing how my product can be pushed through this process so that my intended behavior of the product is taken care of. And any input or the requirement or interaction of the different system or parts in the product are proper or not. What is the advantage of simulation? Easy to understand, easy to test, easy to upgrade, easy to identify the constraints, easy to diagnose problems. So, in a short nutshell, it gives a total kind of arena where the product is going to behave and what kind of probable issues or problems we're going to face in future. Especially, do I understand all the constraints there, or there's a bottleneck in this whole thing? And if I have understood the problems, can I diagnose so that I can find out how do I overcome the problems? Is that upgrade? Are we able to do that? Can I upgrade the product to the next level? Better use, better time consuming decision. So some of the disadvantages. Design is an art which requires domain knowledge, training, and experience. Why I need to do that? Suppose you are from an industry where you do not have the domain knowledge, so you cannot do the simulation of that. For example, I'll give an example of airlines ticket book. Person who is well acknowledged, well aware of the whole airlines operations, if that person is not, then ticket booking, yeah, software developer cannot do it. So it is very important to have a domain knowledge. Same thing for mechanical engineering, electrical engineering, all the aspects. Operation and perform the product, hence sometimes difficult to predict the results. Simulation requires manpower and it is a time-consuming process. Also, it is difficult to translate. It requires experts to understand. Who has understood the whole? It's little expensive nowadays, but it is not that expensive which used to be there a couple of decades back. It's becoming less. Importance of simulation and cost. They're safer and cheaper than expensive real system, real product. They can be more realistic. Yes, as we understand the behavior and interaction, especially about the mathematical tools, the material aspect, we are being more and more realistic with our products. It can be conducted with the real experience in exam, because when the real experience is out of reach, let's say an example. Suppose I have to devise a space launch vehicle. I need to actually simulate it in the ground to see that what kind of things it can do because once I start manufacturing space vehicles and then send it to space and find out, it will be difficult for me to understand all the. So, for example, trajectory, for example, payload issues, for example, performance of these things. So we can actually do simulation. It is faster than real-time issues. It provides an integrative synthetic environment for analysis, testing, and training. Its cost aspect of simulation only in terms of software package price is drop. Actually, there are 3 cost aspects of simulation: purchase, programming, analyzing, and timelessness of research. How quickly I get this is a cost aspect. Different application areas are there in today's world. Talk about medical, talk about industrial engineering, civil engineering, mechanical, natural science, geography, information, military decision support, training, entertainment, everywhere the simulation is very important for us today. You need not go to a aircraft to start flying. You can actually be sitting on a simulator to see how you get feel of the flying aircraft, so that you get simulated, and then you go, so that way you will be understanding better how to fly an aircraft, which is not possible a couple of decades back. So these are basic concepts of product simulations: object, respondent, product, verification, validation. So we talk about simulation. The thing next is simulation technology. What is simulation technology? It can be best described as application of simulation concept with computing capability. And today, in last 2 to 3 decades, this has taken over the scientific and technological world in big way. Big way it has taken over. Simulation, honestly, we used to do simulate earlier, but because the computer capability increase and our growth, we are in a position to better develop this technology, simulation technology. And that is going to impact our product development very strongly. Different types of simulations are there, like physical, mathematical, numerical, interactive, fidelity, accuracy of the simulation, how closely it will imitate the real world process or system, level low, medium, high. Very important. In fact, if we go through this report of National Science Foundation of USA, Simulation Engineering Science, they highlight the potential of using simulation technology and methods to realize the engineering science. Very strong it is working. And today we are seeing in a decade and a half time, we are seeing this impact of the simulation technology in product development. So what and why it is important? It has started getting used in various situations: performance operation of new or augmented technology, safety engineering, testing with natural human systems to gain insight into their functioning. Whether you talk about biological issues, medical issues, or you talk about physical issues, you talk about natural issues, simulation technology is given very strong insight into the situations happening. The key issues in this involve acquisition of valid source information about the relevant selection of key characteristics and behaviors, that is the input, the use of simple learning approximations, the method, and then the kind of accuracy. Connection between product development and simulation technology. This couple of slides I'm going to talk about. A little more think about this. Computer simulation technology CAX is getting integrated with the engineering solution process. CAX is computer engineering, computer design, drafting, computer modeling, manufacturing, computer simulations. Use of simulation technology throughout our product life cycle, especially at the concept and design stage, has potential of benefits like reduced prototyping, shorter time to market, better safety. It is sometimes can reduce your whole product life cycle from concept to market by 30 to 40%, which is going to be a huge impact. Simulation technology is now intuitive to 5 years for its ability to predict behavior of product in the early design phase. You do not go to the manufacturing and then come back and say, oh, this is the issue. No. In the beginning only I can find. Due to integration, complexity, dynamics, distribution, etc., product development increasingly demanding. It has become a key problem in product design process management to predict, evaluate, improve the process through dynamics simulation. How fast I can do with respect to time. And as such, the today's world is a market-driven economy. The product design is becoming more and more complex and fast. The car which you used to have just 2 decades back is now obsolete basically. But there is a mileage, it's a comfort, it is safety, it's coming in obsolete. And if you talk about a car which is 40 years old now, it's totally a history. So today, because of this high market-driven economy, design is complex and fast. Product design and knowledge growth, deeply impacted by human initiative, autonomy, and collaboratively, as well as organ structure, control strategy, and collaborative methods of product design. This pushes the need for high performance computing as an essential tool for such simulation technology. And a lot of this hardware manufacturing in computer industry is looking at this HPC as well as software. How do I make this simulation technology basically a faster, quicker, and accurate? And in the proving stage of product design, physical prototypes are used to check the design's quality, but they are too costly, time consuming, and slow. Thus, the design issue, the simulation phase is taken over that. So, an early insight can help us changes in materials, manufacturing process, etc. before we make the design final. Okay. For example, if I have a materials which is used, like I give an example, most of the materials used in what there are used to be aluminum in the automobile industry, sorry, aircraft industry. Now it's been changing by com- composites. Do I understand the material behavior? Because aircraft is flying in normal conditions over the Earth's surface and can go up to 30, 45,000 feet ceiling where the temperature is low, the pressure is low. How do I behave if the material behaves? So if I understand, it makes a lot of impact. With this simulation technique, trial and error approach is replaced with more rapid iteration. So there is no trial and error issue, and so it gives a lot of understanding in shape into the physics aspect. And simulation practice as designed can be better than a physical test. So I can see the inside of the product and I can change it. For failure analysis cases, refers to simulation in which one create environment conditions to understand the why it's failed. So my product in future may not kind of fail the kind which is to see earlier with less amount. It's real in getting the product first time right. Still time. Now, these are simulation technology. One of the simulation technology is finite element method. This has been able to develop over the last 5 to 6 decades because of advancement in computing capability. As I mentioned, AFM is basically numerical tool. We have discussed in my talk. What it does, it actually breaks down the whole problem. And as I mentioned, that is over a boundary, there's inputs are there from the through inside the system. It does work and we give the output out. So practice that in whole system where some inputs are given and output is as we indicate. And this whole thing mathematically we can simulate to thinking. What it does is basically differential equations and boundary conditions. This we convert into algebraic set of equations solved through computer. So this is the thing. What we have? Field, product. This is open system. The field is product. Action which is coming from outside, external. Reaction, internal. What is I am getting output from internal. And condition which position is going to work the whole system, the whole product. I'll give an example of this. Today we are having mobile telephone. It can work when you're traveling, you can stand, you can slide, wherever. So the product should work in different conditions. So these are basically different areas where the finite method is used and trying to solve the problem and produce products in different aspects. Though the basic physics, structural for all examples, can give different types of structure, mechanical, civil, space, heat transfer, different devices, engines is one of the example. Acoustics, nice. Theaters, halls, fluid flow, for example, your power generating equipments like that. So what is this APM? Basically, actual geometry to analysis is the discretization. We have discussed this aspect, just touching a point on that. It's a typical process in simulation. This actually the whole API is a virtual simulation. Nothing is physical. And I can give me any product, I can do the simulation with the things and tell how the product is going to behave. Was it a mechanical product, civil product, electrical product, or any kind of engineering products basically. And I to when I'm doing the simulation, I need to validate and verify. So verifications between validations physical to mathematical, verification is mathematical to numerical. So you have touched upon, but I'm just touching this point. Now some of these examples are developed through simulation technology. Look at the aerospace industry. Earlier it used to be quite difficult, it used to be taking time. Now today we know this is what my load so many people will be carried by aircraft. This much load is to go. This is a distance. This is a, so I can actually make a model of that, simulate it through, and find out what kind of distance. It's a mechanical system. So how much it can carry. And once I know this, if I give an example, it is the most important thing that the aircraft works from ground, where the density of air is different, The temperature is different to higher ups at the air. Ceiling height of normal is 40,000 feet. Temperature is different, pressure is different. And as it is stretching down, going up, so fatigue loading is coming. How long a structure will be proper? Similarly for turbo machinery, automobile, these three are pure engineering where time is important. These are actual things made in India. This is one of the actual hydro turbine which generates 130 megawatt kind of power in single. This side impact aspect of automobile, the engine crankshaft. So look at this, all we are simulating today in our country and giving. These are the actual product made in India. Biomedical devices, the replacement of knee joints, your lungs and all. Sports, look at the kind of things, the shoes we are talking about. Okay, the kind of where I should hit so that I get a maximum output but minimum impact. Hockey sticks. So all these products are basically now can be simulated for a better output. Some examples like housing, this distribution, temperature distribution, housing. I can simulate it in every phase of that and out. Stamping, okay, stamping assembly, simulation through finite element. We can actually develop this product. Crack propagation. Now, why you need to study? When I am shearing a steel plate or steel sheet, how am I going to get the edges? Very important for us. If I get a smooth edge, then my kind of wastage is less and I can get a better product. So how do I study? These are simulations that bring in the kind of speed, the impact, the results. Forming. This is orbital forming. Very interesting on how much stress is getting developed. Why we need to study all these things so that the kind of life it can go through, can give me, and the kind of products, mode functioning, everything will be done through that. This is a given steering opinion. Very important for automobile industry, and it has all been done in this country today's world. Die design people. Okay, the whole thing is modeled, okay? And we find out the stresses getting developed so that what is the life of die? Because each die is very costly. Designing and manufacturing die is costly. So if I can make from one die, if I can get a 100,000 product or simple component sample, the parts, this works for. So you have to have the simulation of this product completely. Some of the hot products have given some issues. Okay. Different types of vehicles, cars, bikes. Okay. Now, moment we talk about products of the future, intelligent refrigerators will track food inventories. I recollect a talk about 2 decades back when we talked about the intelligent refrigerators. It was a kind of imagination, but today it is a kind of things coming up. Moment I open the refrigerator, send me a signal or kind of soft copy that this is what we have and which you have consumed today. I can send a copy to my home delivery service that the drinks is less or the food is this, bread is less and this and that. Indian wallpaper will transform a wall to television. A computer screen walks apart and it's all to become a reality wallpaper. Robotic lawn mowers will paint the grass within any specific boundary. Holographic storage will be used to store and retrieve home videos. So smart equipment, everything is becoming reality. Not all new products are planned. Interesting, let me talk. Microwave ovens, NutraSweet, Scotch Guard, Teflon, penicillin, etc. Each case an accidental disc. I mentioned this in the beginning of my talk. Somehow they knew they had something when they saw it. They did not intend to make, but it came. The conflicting masters of new products management. This is the important aspect. We talked about all the interesting things aspect of product development through simulation technology. But then this conflicting masters of 3 inputs to the new product process: the right quality product at the right time and the right cost. Very important. This conflict with each other, but they may have synergies too. We have to understand the right quality product at the right time and the right cost. I cannot play and separately and without understanding them together. So how to optimize this relationship in new product situation? Once we master this, we have these things. breakthrough innovations that change our lives. If you look at this, and in this, I should say, lot things have been done by Indian and in this country as well as implemented. For example, if you look at the kind of different uh, aspect, communication satellite, India is now satellite launching. India is one of the major things. Okay. What is the next? Innovative products to market with reducing product cost and maintaining product quality. Digital design, validation using simulation techniques allow organizations help to meet the above demands. The simulation technology helps these organizations raise the bar in their products and help them gain better insight and understand the physical behavior of products when testing ever could. Physical testing, you can do 2 or 3 parameters, and again you have to find out or do again for another point. But in one go, like this example I've given to Feidelman, one analysis can give me all the outputs I need. Its simulation technology helps improve the innovate, allowing freedom to test new concepts of products with confidence. It can optimize space and weight, cost, and metal reduction. It's tremendous things. So, what are the next things we're talking about? Virtual product design. It is the use of VR technology to produce the product design with virtual environment. We do not do the physical things. Historic problem design, build, test, this design can be solved by using simulation technology and in the product design process. So we're going to constant time together. Virtual ergonomic simulation, very important. Example, you're driving a car. Or you can drive for 6 to 7 hours without discomfort. I can create the ergonomics. I manufacture something, I can use it in the same place for 2-3 hours and manufacture it. I'll not get disturbed. I'm reading some books, the chair should be proper. So this is a VES program. It uses visual models, which is mimicking the whole posture, loads, performance, and everything. So they are recognized as an evolving and valuable tool for this was unthinkable about 2 decades back. So this kind of VPD we're talking about. Real world performance is predicted and studied with simulation. It is the foundation of simulation driven product design. And today another topic is DPD. So this is the next extension of what we discussed today about product design simulation, simulation-driven product design concept. And this is taking up slowly in major areas like space engineering and critical areas like nuclear and all this. Shortening and eliminating the cycle needed for physical testing near the end of the design. VP, the virtual product gives product designers right time to identify things. It leads to fewer, better, harder products like that serves to because you have understood all the inputs and output and how they interact. Any loopholes are there or not. Next is KBE, knowledge-based engineering. The product development process is inherently a knowledge intensive activity. So great deal of emphasis on knowledge-based engineering is important. Okay. Adaptive mathematical models, generic algorithms, agent-based models have become important things. Lately, along with artificial intelligence to automate PD, it has started playing a major role in product development. So KB is important for us. So what is to conclude? It can conclude that simulation technology is very important in making product design a systematic and innovative process in an integrated manner. Typically in the Indian context, you see the Indian context, but a lot of places where we are not present even 3 decades back, we're very much there in that today. And we are doing fantastically good, like space engineering, nuclear simulation technology, or any kind of weapons systems or metal systems, software design development. In that, in fact, we are the best in the world today. We conceptualize to make things happen. Throughout this PD process, simulation technology plays a significant role, especially in evaluation of alternative designs, iterative modifications of design, and collaboration between different groups. A large number of product concepts for a good product can be evaluated with simulation technology before detailed product design starts. It guides the direction of the product design to optimally satisfy requirements such as performance, reliability, sustainability, and optimal cost. For a good product, I am ready to pay, but can it be there, reliable, nick of time, it gives me service. So this is a kind of validation verification of simulation. Is abstract the conceptual model, how the whole things. If you look at real world conceptual models, it's all together and it gives me better product. So product design development simulation in the world we live, Better understanding and application of product design development through simulation will lead to better engineering of products and balanced society. So we have to put three things together to have a better balanced society. And that's what we have to mean, ladies and gentlemen. Thank you very much for patiently hearing questions. Thank you.